Okay, I'm starting right now. I'm going to start with the projectile data lab. So right here, am just on the home page. You have 4 different tabs at the bottom. Each of them can measure different things. I'm going to be on the variability. Is variability orientation is what I'm going to use for determining the velocity of 3 different projectiles, but all of them have different applications for whatever you're determining. So right here on the left-hand side, we have orientation, projectile, mystery launcher, measuring tape, stopwatch. Sources allow you to customize the launcher. Measures allow you to have this program determine the mean, standard deviations, and values. And the sampling allows different sample sizes 2, 5, 15, 40 it's a single sample. So I'm going to have right now, I had 5 different, which is the sample size, 5 different projectiles fired, and it calculates the sample size, or excuse me, it calculates the mean for the 5 different projectiles of the sample. So it's 46.8 meters per second, or 46.8 meters was the mean distance. I'm going to go back to the variability tab. So what I'm going to calculate is the velocity of 3 different projectiles. And when I first started this experiment, I thought the velocity would be the same of all the projectiles if I didn't change the orientation, projectile, or the mystery launcher, but I was incorrect. The projectile or the velocity does change. The equation to measure the velocity is the displacement divided by the time. So displacement is distance, so we are going to need the measuring tape feature and the stopwatch feature, which we'll need that for time, which is going to measure in seconds. So I pulled up my calculator too, so I can calculate the velocity. So I'm going to launch the first projectile. So I'm going to press launch. And as you can see, when I stopped it, so 51 meters is the distance or displacement. So in order to determine that, 51, and I'm going to divide that by the time, which is 2.74. So I'm going to round to 2 decimal places because sometimes velocities are similar. So the velocity of the first projectile is going to be 18.61. In the second velocity, I'm going to use the same formula. So I'm going to launch the second projectile. So the second projectile, there's 50 meters. So 49, 48, 47. I would say it's 46.5. So I'm going to take, right on the calculator, I'm going to take 46.5 and I'm going to divide that by the time of full in seconds, so that it'll be a meters per second is velocity. And I got 18.02, rounded to 2 decimal places. And then for the third velocity, I am going to launch the third projectile, and that is right at 50 meters. So I'm going to clear that out and calculate 50 meters divided by 2.67 seconds. I don't know if that, I'm going to clear that out one more time. So 50 divided, Sorry about that, guys. 50 divided by, need to all clear this. 50 divided by, oh, what's, I'm not sure what it's doing. Give me 1 second. 50 divided by 2.67. And I got the answer of 18.73 if you round to two decimal places for the third velocity. So as you can see, the velocity is different for all three of the projectiles. And the reason this is even though not the orientation, projectile, mystery launcher, all of these variables are staying the same. Gravity acting upon the object, as well as you can have a different force or a different whatever is shooting out the velocity or shooting out the projectile makes the arc different, or the parabolic arc or launch path, as you can see right here, different. That makes the time and the distance different. So, but basically gravity acting upon it because there is no air resistance. So yeah,